Should we wait? We'll wait like 1 or 2 more minutes. We just started 1 minute ago. So I'm Jeremy Davis. I'm a chief architect at Red Hat. I specialize in app dev technologies. I've been at Red Hat now for 10 years. So the company's grown quite a bit. We have a lot of new stuff in our portfolio. Only a handful of products when I joined, and I think we had a couple thousand people when I joined. Today we're about 15,000. And of course we were bought by IBM. So we're part of a larger company, although we're an independent company still at present. Devin, when he joins back in, I'll let him introduce him. There you go.
Oh, I'm here. I'm mostly just here for moral support. Jeremy put this all together himself, and originally it was going to be a workshop, and I figured he would like some assistance in helping you all work through your labs. But when it went virtual, we decided to run this just as a session. So.
Yeah, so no hands-on workshop today. We are working on getting a virtual version of that up. And Devin has been one of our consultants, was in Red Hat Open Innovation Labs, which I'll talk a little bit about later. And so feel free to shoot out questions. He's led some of the exercises that we'll talk about in this presentation. And I will go ahead and start the talk. Also, fire things away in chat. I'm going to be sharing my screen. So, Devin, if there's some questions in chat, just speak up, interrupt me. If you guys can unmute, feel free to interrupt me as well. We've got, I think, an hour, and I can certainly hang around longer, and I'm really easy to reach if you want to take any of this stuff afterwards. So I will now share my screen, and we'll start presenting. Right. And so, yeah, thanks to our presenters here. Really excited to be asked or to have my talk accepted here. And unfortunately, I'm not in Louisville. Really was looking forward to Louisville. So our talk today is event-driven architecture with Quarkus, Kafka, and Kubernetes, which rolls off the tongue nicely. So first things first, a little bit about me. I'm a chief architect at Red Hat. You can reach me at Arrogant Programmer on Twitter. I'll respond pretty quickly. I'm easy to get in touch with. And we're going to be talking about events. Now, I'm assuming everybody's familiar with GitHub, or at least some sort of source control. And I had this picture here, not just because this is where you can get all the source code that I'm using for the presentation, but this is a good example of storing events, right? Every time you make a commit, Git stores all of these events, and you can go back through time and you can see how these things change. And so this is a system that's built on events. It's not event-driven architecture, but it's a system that everybody is familiar with, right? And it gives you a lot of the advantages that we can do, or some of the things that we can do with event-driven systems, right? Because we can replay, we can go back in time to the first commit, and we can analyze things that change. If we want to go back in time, we can do that. And one of the advantages of building event-driven systems is when we store our events, we can go back and learn about our system in that same way, right? So we can replay events that came through our system. Okay. All right. Now, what we're going to talk about, the example we have built is called the Quarkus Coffee Shop. And you might be thinking that I did this because I'm pretty nostalgic about being able to go and work in coffee shops, because I mostly work out of my house. And one thing I really like, I have a couple of coffee shops within walking distance. I really love going and working in these coffee shops. But I actually had this idea. I stole this idea from Clement Escoffier, who is who's our chief architect for reactive programming in our engineering, in Red Hat engineering. And he had a sort of rudimentary demo that we expounded upon to build the Quarkus Coffee Shop. So I thought, for starters, let's just go ahead and jump right in and take a look at what this application does. So our application here, well, this is our Quarkus Coffee Shop. Let's hide that. And so you notice we have our barista here, a little background about Quarkus and our demo here. Here's our menu of stuff that we offer. We have a pretty simple menu here: black coffee, coffee with room, espressos, cappuccinos, and just some various pre-made baked goods, right? Not unlike your neighborhood coffee shop. What we're going to do is, when our orders get placed, we're going to display our order, the status of our order in here. So your order, you'll see that your order is being made, and then you'll see when it's ready. And then you can meet our team of baristas. These guys aren't actually baristas. This is the guy here, Clement Escoffier, that I stole the demo from. If you're familiar with the Hibernate object relational mapping framework, this guy was the lead on that. Jason and Ken and Max were some of the leads for Wildfly and JBoss application server before that. And these are the guys that built Quarkus. We've also got some Twitter quotes here. If you tweet about Quarkus or tweet to me, you could end up in here if you want. I'll ask you permission first, though. I got everybody's permission before displaying on the page. And then some other fun stuff, right? So the idea is this is our local cafe. So let's place an order here. And I like my coffee black, so we will add my coffee there. And Devin, do you like cream in your coffee? So I'll assume that Devin likes cream and sugar in his coffee, right? So we'll add Devin in there.
Black is my soul.
Oh, all right. Sorry. Well, you have room for cream if you want. And I'll place the order here. You notice both of us have our coffees getting made. They're in progress, and they're now ready. And this is my local one. I also have this running on AWS as well. So they were prepared by our machine name. That's the name of the barista, which is the name of my my laptop. Now, that's our basic demo, right? This is our application. So it's a pretty simple application, right? It looks pretty simple. Obviously, there's going to be it's overly complicated, right? Because that's what you do with demos. So we'll go back here to our slides. Now that you have an idea of what we're looking at. So what we just saw was an application built with an event-driven architecture. And the website in this case was an event producer. We would go to the website, and I, order some drinks or some food, and then that puts a message onto a Kafka topic, right? So it sends a message. In this case, the message it sends is a command. We'll jump into that a bit later. That goes to the core of the application, which is the orchestrator of the system. So events come in and out of the core, and the core orchestrates those. Depending upon what it gets, it creates new events, handles business logic, handles persistence. Everything gets orchestrated there. It then sends out messages, or it sends out events to baristas, which are both consumers and producers of events, and the kitchen, which is also a consumer and a producer of events, right? So the barista and the kitchen consume events from the core of the core engine, and then they produce events once they're actually finished making things. All right, so let's take a little core engine here. We have a Kafka service. And this Kafka service, hopefully this font is big enough for you guys to see. If you need anything, also just please speak up or type something in the chat if you want to see anything bigger. If you can't see, let me know. If you notice, we have an incoming, and this is Quarkus reactive messaging. And so we just give this annotation of the web in channel, right? And this comes in, and we handle our create order command, which is the payload we get from our message. So we take our create order command, and then we send off events, right? So we send our events out to barista and to kitchen. So our barista is pretty basic. It also has a Kafka service. There's not as much going on, right? It's got a Kafka service, and then our barista is the core logic. So we have an order in event. And what I'm doing, all of my order in events, I check to see that my order in event is a beverage order in, right, or barista order in. And if it is, I make the order, and then I send out another message. And in my barista, our business logic here is pretty simple. All we're really doing, we have our string made by, which is just being set to the host name, right? So get a host name. And all we do on make is we just add some time, right? So depending upon whatever beverage somebody's ordered, we just sleep for a couple of seconds, right? So default, if it doesn't come in, we last a long time. Cappuccinos take longer than a black coffee, right? Espressos take longer as well. So pretty simple. The kitchen does essentially the same thing. There's not a lot of difference in these two pieces of code, but this is where we're handling our business logic. In this case, we're processing the making of drinks or kitchen, but you could be doing calculations. You could be kicking off some external process. It doesn't really matter. The key piece here is we send in an order in event. So let's talk about why we have order in events. All right, so event storming, right? There's two main topics I want to talk about: domain-driven design and event storming. But I wanted to start with events because events are at the heart of the system. Whoops, let me go back one. So this book is by Alberto Brandolini. He's the guy that came up with this concept. Eventstorming.com. I'll make these slides available. I'm sure the conference will send them out to you. I'll also put them up on SlideShare, and I'll broadcast it out on Twitter if you want to copy the slides. So eventstorming.com, and you can get this book there. Really great book, and he walks over. He's the guy that invented this, and he goes over a number of different scenarios in which you can use that you can do event storming. This is an example of what an event storm looks like, and this is Red Hat's London office. So you can see the Thames River back there behind this board, and this is a panoramic picture. So this is a huge long board. This is about 20 feet or so long of an event storming session, right? And you go in, if you look at these colors mean something. So the colors are a convention, and you should follow that convention, and you get a bunch of people in a room who are tied to the system, and you create this event storm. So the idea is we want to capture all of the events that our system cares about, right? So our cafe cares about an order being placed, right? It cares when an order is ready. It cares if a customer asks for a refund, right? Or if we have to remake an order, right? Somebody didn't get their drink, or they spilled their drink, or they didn't like it, right? So those are events that have meaning and that we need to take some kind of action on. Now, what the colors mean, we use yellow for users. Domain events are orange, and those are the key. You need a lot of orange sticky notes when you do event storming. And events are always in a past tense, like order placed, right? Order finished, order created. Aggregates are our domain objects and a way to encapsulate object-oriented programming or apply good object-oriented programming practices. And then commands are an order. So it's not really an event, but it's an order to do something. For instance, my website places a create order command. So it sends a command in to the core system. The core system then takes that and creates events. Other things that we'll deal with too, you can create a view, obviously when you're designing your UI. Business processes, you annotate that we have a process for this. Like maybe if a customer registers, we have a process that handles that registration, like, email confirmation, maybe we store their credit card number, right? If like in your Starbucks app, things like that. And then pink is used for external systems. If an external system to your bounded context, which I'll talk about in a second, is. So this is an example event storm that I did with a couple of colleagues. So Devin and I and a couple other people did this around part of the system. And this was for the customer home office events. So the back office, the individual cafe, we're talking about making drinks. Like you walk into an individual cafe, you're interested in drinks and food and maybe buying dry goods. The home office needs to know about every order that gets placed, right? So we have an individual cafe, an external system, sends in an order placed event. And then when that event comes into the system, it's going to operate on two different aggregates here. So we have order and we have customer. And this is the order aggregate means it's one order, but it might have multiple individual line items or other data about it. The customer could be also a piece of this, right? If the customer's logged in for loyalty, right? And that same customer as well. So if there's a customer object, we want to give them loyalty points for everything they order, right? Because you have to have a loyalty program today if you exist at all, right? And then these are actions or commands that happen, right? So order comes in, we need to persist the order because we're going to store every order from all of our stores, and then later we'll reconcile all that, right? If the customer loyalty needs to be updated with their loyalty points. And so we go through these various scenarios for all of these various things, right? So orders completed, orders refunded, right? Orders remade. We want to track remade orders because some baristas are better than others. And maybe we want to hand out bonuses to baristas that, never make mistakes, right? Or if we're getting a lot of remakes on a particular, drink, maybe we want to change the flavor profile for, our pumpkin spice latte thing, right? Now, what brings all this together, and this is the other sort of big idea behind coding, is domain-driven design. And this is how we take events and turn them into something that resembles code. Because event storming helps you understand your business. It doesn't have to result in software. And one of the things that Brandolini talks about is how you can use event storming just to sort of increase your own business processes. It's typically used with software, but it doesn't have to be. And there are there are advantages to using it just inside of your business. Now, Eric Evans and Vaughn Vernon are the two main guys to read. This domain-driven design, Eric Evans' book, is fantastic. It's kind of the Bible in it. And then Vaughn Vernon's written two books, Implementing Domain-Driven Design, which has some code examples in C#. And then his other one is more famous.
DDD
Both
Distilled.
of these Domain-Driven Design Distilled is a more common read. But all three of these great books. But I definitely would recommend starting with Domain-Driven Design by Eric Evans. Now, the key concept.
I disagree. I would start with the Domain-Driven Design Distilled. The Evans book is great, but it's dense. It's really academic.
Okay. So you can so you might want to start with Domain Design Distilled instead. Maybe I just happened to start with Evans, so that was just my starting point. Now, key concepts that you have in here. Ubiquitous language we're going to talk a lot about because ubiquitous language is very key to the system and it's incredibly useful. Bounded contexts are the other big thing. Again, incredibly useful, and they've been revisited in the microservices era because it also turns out to dovetail nicely with the creation of microservices, right? Domain events, again, we talked about the centrality of events to what we're doing, and then aggregates, value object services, and repositories. We'll jump into some of that. It's ways to organize your code, and it's a very different way to organize your code than if you remember the MVC pattern. Like when I started out my career, the MVC pattern was the thing, right? And whenever I went for an interview, sketch out the MVC pattern, right? You had to whiteboard what that meant. This is a different way of looking about things. We don't care. We don't want to organize things in terms of persistence, right? Don't want to do that at all. And we'll take a look at some of that. Now, bounded contexts set the boundaries, right, of what we're talking about. So the bounded context we're looking at here is the cafe, right? This is what goes on in an individual cafe. Somebody makes orders, somebody makes the drinks, somebody, heats up the croissants. But there's other bounded contexts inside of our organization, right? There's the home office. We looked at the event storm or an event storm for the home office a second ago. There's also the inventory system. There's a customer loyalty system, right? So you have to have an area that handles all these. Each of these are individual bounded contexts. If you want to follow the two pizza team kind of thing, I don't think it necessarily has to do that. But the one thing that's core here is you want to have a business owner that represents each of these, right? So you really want to design your software in collaboration with a business owner for that domain. So we want to talk to somebody, who's a store manager or who's a barista or who works in the kitchen, right? So that we understand their domain space. In the home office, we want to talk to somebody that works in the home office, right? That wants to talk about the metrics that I want to see, right? What's really important to me. And we need to be able to talk in those people's language. Like customer loyalty, we're going to talk to a marketer, most likely, right? And we want to talk inside of those people's language. And that's where ubiquitous language comes into play. And I recently was working with some of my colleagues on a sales team and gave them a talk on ubiquitous language because the term their customer was using a term that Red Hat uses for a different meaning, right? So Red Hat meant one thing by this, the customer means something else. It's called polysemy, right? So this is a thing that we have in the world where one good example I heard about was somebody talking about doing software for electrical grids, right? And so the notion of a connection is different depending upon where you're talking about, like your house to the grid or grids to other grids. So the same word can have different meanings, even in what's kind of the same space. And some of the ubiquitous language that we have or that we're using in this example is order in, not order placed, and order up, not order ready or order complete. And the reason for that is in the restaurant space, that's how you say it. And I know that because I did restaurants for years through college, right? So you say an order is in, not an order, placed. We say order up instead of order ready. Another thing we say, instead of saying item is out or we're out of an item, you say an item is 86th. I don't really know why. I've heard rumors and stories of why. But in the restaurant industry, if something is 86, it means you're out of that. So if we 86 cream, we don't have any more heavy cream. So you want to work in the domain language of your customers, right? So you don't give them some language that they've never heard before. This happened to me once in my career. I know somebody designed a system. We built this system. We got specs. It's an old-fashioned waterfall. I think it's a long time ago. Old-fashioned waterfall development, right? We had this huge documentation from the business analysts, and we built this thing out perfectly, right? We hit everything on place. We did it really quickly. We had a really, nice UI. We were really proud of the work we did. We bring in the business owners, show this off. Think it's a Friday afternoon. We're thinking we're gonna, leave. It's beer 30, right? We successful couple of months here, and it was me and another developer for almost 3 months. And the business owners, they look at it and they're kind of quiet when we finish, and we said, "So what do you guys think?" And they said, "Wow, it looks really nice." These pages, they're talking about how nice the design looks. Well, I'm not really a front end guy. I mean, I started as a front end guy, but not a designer. So I've done a lot of web stuff, but I'm not the designer, right? So I said, "Okay, but what else?" And they said, "Well, it doesn't really match our business." Right. So this business analyst had come in and created this application that didn't match the business. Now we were using waterfall, so of course we spent a lot of money and time before we caught that. But this is part of the key thing about using this ubiquitous language and continually refining it. That's another piece. Is you want to continually refine the ubiquitous language and constantly refactor this language. But you don't want to create something that forces other people to use this either. So you want the ubiquitous language to marry inside your bounded context. So while we might say order in and order up at the cafe level, in the home office, we might say order placed and order ready or order completed, right? Because that's the language that they use in the home office. And this is a really great concept. I like this concept a lot. Now, other things we'll talk about: aggregates, entities, value objects. Some of this, to me, aggregates, to me, this is not as confusing a concept because we've been using object relational mapping. And I sort of thought about it, if you go back to the days when we had to hand tool SQL or for everything, then you would have your customer in one table and every order and every line item in different tables, and you did all these multiple queries, and sometimes you would just kind of keep these things together. But once we did object relational mapping, then it became a little more intuitive anyway, right? We had a customer, and that customer had orders, right? A collection of orders. So that made a lot more sense anyway. But the other thing that aggregates do is that aggregates are where we implement our business logic, right? So an aggregate implements our business logic. So our order is in charge of creating an order created event, right? And that's where all of the logic around our order gets encapsulated inside of that object, right? It's basic object-oriented design practices. Value objects are things that are important to the system, like in our case, a line item, but that don't have any persistent value. We don't really care about them beyond the notion that other people need to know about them. So like my barista needs to know about a line item that he or she needs to make, but the system doesn't care about persisting each and every individual line item, or they don't have any importance outside of the parent object. Other things we'll look at: services and repositories. And so we'll jump into a little more demo or a little bit of looking at code to check out how I've implemented some of this and how we're doing on time. All right, so that's our barista. Let's close the barista there. We already looked at that guy. So our order, I'll talk about this register for reflection in a moment. That's a Quarkus thing. But our order, we're going to persist this order, and that's why I said this field is transient, right? We're not going to persist our logger. And here's our ID. It's bson. We're using MongoDB. I've got line items. And one thing that's nice about Mongo, because it's a document store database, it makes it really easy to persist JSON. If I was doing SQL, traditional SQL database, right? We are a relational database. What we would do is I would have, a separate table of each line item, and we'd have a mapping table or a foreign key, right? We'd go get those. It's really easy to do inside of Mongo because you just save your document, which is really nice. But the order itself is in charge of things like process, create, order, command, right? I mentioned that our web is going to send, the web site is going to send in a command object onto a Kafka topic. We're going to read that topic, and then we're going to process that order. And we create an order object from that command. And this just tells us the logic, which isn't very complicated here, but we essentially just loop through things here and create our beverage line items and kitchen line items, right? And then this comes back. I'm getting text. Let me turn that off. Sorry about that. this comes back, we create our object, right? So that's our order. This is our aggregate because it stores these other objects and it creates our value objects. It applies that business logic and then creates it. Now our service is doing the orchestration. The Kafka service is orchestrating what has to happen. So it doesn't, or we try to contain as little business logic as possible, right? Oops. Wrong Kafka service. My Kafka service that I want is right here. So the Kafka service is orchestrating, right? Our order comes in from web in, and then we create order command from our JSON payload. Get our JSON payload back. It's just a utility object. So we get our order created event from our order. Our order handles all the logic to create this event. And then we persist it using a repository. Repository pattern, if you've ever used like Spring, this is pretty familiar looking. This order repository in here, this is all the code you need for that. And this is Panache, which is a new dynamic feature of Hibernate. So Hibernate Panache, essentially we just give an order to the repository and it automatically implements a whole bunch of methods, right? So we don't have to do anything to get, things like save, update, retrieve, all sorts of methods just come for free, right? And we just say repository and we get our method back. So persist, you can see other things like order repository. Count, delete all, delete by ID, find, we can pass in query objects. So all of this just comes out of the box for free. You make it really quick and easy to use, which is one reason Quarkus is really nice and friendly to use. So one thing I've done too, I have a domain here where I store most of my objects, my domain objects. So my create order command, right? I have a command here. I've got line items, which again are value objects, right? I'm not persisting these. These don't really have anything on their own. And I have my events in here. So we have an order in event, right? And an order up event. So we're using the language that's going to make sense for our domain, right? Our ubiquitous language. And we have our events. And these events go into the system. Yeah, they go into the system as JSON. And I've got a JSON utility that under the covers just gets a create order command from JSON and marshals back and forth to strings, right? So dashboard updates, when I go to update the dashboard, that goes to JSON. So I have a little utility class to do that inside my objects. It makes it really easy to marshal back and forth. So all you have to do here is pass in your JSON payload and the class you want, and you get that back. All right, so Apache Kafka, I mentioned a few times, we're communicating using Kafka. Now, you can do all this through REST. It's pretty easy to do REST, but one of the disadvantages of REST, obviously, is if it goes down, then you have to deal with failure somehow. Kafka makes it really nice. One, it's super fast, but also stores everything for you. And why this marries really nicely with event-driven architecture goes back to the difference between Kafka and a database, the difference between storing events and being able to replay events in the way that GitHub works, like we started talking about GitHub, as opposed to the way that a database works. And by the way, at Red Hat, we rename everything. I usually joke that we do that so you can't tell what we sell using Google or what we commit code to using Google. We kind of hide everything behind some name. So for Kafka, for us, means it's AMQ streams, but it's Kafka, right? And we commit to a number of different Kafka projects. But in a relational database world, we would have our order or a cup of coffee, right? And we would insert it, and then we would update that order, right? So we would insert our order, and we would have a status column, and that status column is like new, and then in progress, and then ready, right? And we would update that. Well, Kafka doesn't work that way. With Kafka, we get an order, and then we get another order, and then we have another record about order, number 1, 2, 3. And so that way we record every single event. So similar to the way that Git works with every commit, right? Kafka's appending these events, or Kafka works this way by appending things based on their key. But in an event system, this makes it very easy to adapt to Kafka, right? We just append every single event. So, we have an order in event, we have an order up event, but we have a primary key ID for every one of those, right? So we can just kind of pull every one of those events out. That also means that if we persist the raw events, we can go back and replay. So if we ever want to like pull off all of these raw events and we want to test our system for load, we can go back and replay events and find out like why a crash happened, right? Or we can also get back to certain states. And one technique typically you do, obviously in a cafe, you wouldn't need this, but you can sort of save these off to a state and you have snapshot, point in time snapshots. In a bigger system, that would be something that would be important. Not so terribly important when we're making coffee. But the way this works, Kafka, it has traditional messaging brokers, right? You have producers and you have consumers. So in our architecture, the website is both producing and consuming, right? So when I ordered online, it's going to produce a create order command and send that into the system. The core in that case is a consumer that goes into the web in topic, right? Then the core will produce a message, which it will send out to the orders topic, right? And then the consumer will be the barista or the kitchen. They'll consume those orders, and then they will produce an order up event, back to the same topic. The core is then a consumer of that message, and then sends out a web update for which the website is a consumer. We then stream that out using server sent events to the front end, and that's when you see the little dashboard that's server sent events coming through. All right, so the next piece here is Quarkus, Kafka, and Kubernetes. So that's why we use Kafka as messaging. One, it's resilient, right? It's easy to replay, and it marries really nicely with this paradigm. So Quarkus also marries really nicely with this paradigm, and we'll take a look at why. So let's go back to a little bit of code. We've seen some stuff in IntelliJ, so let's see me running the system on my laptop. One thing that's really nice, I am running like if you ever used Java application servers, I'm essentially running 4 servers right here on my laptop. I'm also running Docker Compose, so I've got Mongo running here, I've got Kafka running here. I'm also inside Hopin, right, presenting a conference, and I've got an IDE. It's a super tiny amount of memory, and I'll show you. We'll just stop right there. So we stop really fast, and Quarkus has something called dev mode. You know what? Let me. You guys see that okay? Quarkus has something called dev mode, and what this is going to do, it's going to boot up, and it's going to clean. I'm going to compile, and then it's going to boot up, and it's going to listen for changes. So it'll watch my system to see if anything changes. Boots up a little bit slow. Connecting to Kafka gets a little bit slow here. But you notice here we've connected to Kafka. We're running. We're ready for live coding. I've got various features installed. It's also Quarkus is also very modular. And you add in pieces by default. We can grab our pieces. We have a lot of pieces here.
Hey, Jeremy, can you zoom in a bit?
Yep. So these are the installed features that I'm using. So I'm using kind of a bunch of stuff on here, right? I'm also running on the JVM. So I'm running on a regular JVM. That is kind of important because I'll mention that in a second. We can compile down to native code using GraalVM. So Quarkus was written with the notion of Kubernetes and cloud native Java in mind. One of the things that Java was great at optimizing memory for long-running applications, but it used a lot of memory because for a long time, memory was really cheap. Well, now we start paying for CPU cycles and memory in the cloud. Memory is a lot more expensive, and Java was a hog in that respect. And so GraalVM, which is a project that came out of Oracle's labs, it's now the core of it is open sourced. We're Red Hat's contributors to it. Graal allows you to compile down to a native code. So we will literally compile a native image, wrap that in a Docker container, and then we get super, super fast start times. Here, I'm going to go to start.quarkus.io, and here I can come out and build my application. I can check everything I want. I want JAX-RS. For REST, I can do JSON. If I want to use the Hibernate Validator for validation. Data stuff, I want to use Hibernate, or I want to use Hibernate with Panache, which is really nice. JDBC drivers. You look down here, there's a lot of different stuff in here. If I want to do reactive programming, I have our own reactive libraries in here. There's all kinds of cloud-ready stuff that we can pull in for here. And it's labeled nicely, so if it's experimental, your mileage may vary, right? If you do integration work, a lot of camel stuff in here. So you can do all kinds of different integration pieces inside of here. So you can get started here, and then this allows you to just download your code. There's also a lot of guidelines here. So if we go back, there's a guide for just about anything that you want to do in here, right? So you want to look at testing, we can do that, configuring logging, writing native applications. Now, I mentioned that we can compile down to native, and there are some odd things that you have to do to native. When I had that register for reflection thing here, that's what it's doing. So reflection is one of the things that's harder to do inside of Graal. So what Graal does, and typically in Java used to compile your whole application, but it would include everything in the JDK, and it didn't necessarily even know if you used everything. And then while your application's running, the hotspot would go back and recompile and shift around the way memory gets managed to make your application more efficient. Well, if we're going to do native, we can't do that. So Graal goes through, it essentially prunes your application. It throws out anything you're not using. So it'll find a class you're not using, and it won't compile it into your eventual binary. But when we do that, you have to take a few things. You have to take a couple of things to be careful of. Now, the way you do it, you can stop this and so we can, whoops. We just use Maven to package this, and we give it a native command. And we just give it a profile, Maven P profile, and we say compile to native. Now, this can take a while, and it can use up a lot of memory. I won't actually let it run all the way through here. You can also compile it with a JVM, because some applications will actually run faster on a traditional JVM because of the memory management in the JDK. But if you notice here, what we're doing, we're going through a lot. I'm going to hit pause because I could end up running out of memory while I'm running a bunch of other stuff. So we can compile down to a native binary. We can then wrap that inside of a Docker file. We can also compile down to a Java binary and wrap that inside of a Docker file. And that I've got both of those running here inside of OpenShift. And if we look at CPU usage and memory usage, they'll be different, right? With the different pieces of these microservices. So I've got a couple in JVM mode. They're going to be using more memory, but they'll be more efficient for certain workloads. And then I've got several that are native, which are going to be more efficient for other workloads. But we can look in through here. Even so, we're not using too much memory that I got a lot of stuff running inside of here. So I've got MongoDB, I've got Kafka, I've got 7 different microservices, and we're still only using a couple of gigs of memory, which is pretty good. And this is running on OpenShift inside of AWS. All right, and so Kubernetes, we just kind of jumped into that. So OpenShift is Red Hat's build of Kubernetes with other stuff involved, right? So we've been involved in Kubernetes pretty much since day one. So Google originally reached out to us when they were looking to open source it and asked if we wanted to collaborate on it, and we said yes. And so we've driven a lot of the features in the product. So we're a little bit ahead in some terms, and we've done some things that I think are a little bit nicer than some of the things that have come later. We typically go back and adjust to the community. And the reason we want to do this is my topology, right? So if I was to do this in VMs, this would be pretty tough to do, right? I've got, Kafka running. Kafka itself runs Zookeeper under the covers. If you've ever stood up Kafka, it's a bear to stand up. Well, OpenShift has something called operators, and it makes it really easy to stand up. And an operator is essentially a state, a definition of state. And so when we create operators in Red Hat, let's take a look at this. So Red Hat created an operator for AMQ streams or Kafka, right? Because we rename everything. Let's go to our operators, installed operators. And I've got a couple of these installed. It's spun up Kafka. So what an operator does is it defines the state. So I always want X number of nodes. I want, Zookeeper. I need all this stuff in place. And then it allows us as developers to simply do a one-click install and then come in and very easily define our topics, right? So I don't have to go in and, log into Kafka and do this with the command line. I can come in and just create Kafka topics this way, right? And I can edit YAML directly if I want. But we make it really easy to come in and do this. I can see all my topics. I can get some window around how it's working, right? What do we have in here? Oh, okay, not much going on with it. But it makes it really easy to do that. So we can set up, and you can create operators for your own applications as well. I think it's a little more common to see Helm charts, right? And then we also come in and we can see this entire topology, and we can drill down into some of these. Like this thing's not running right now, so let's turn this thing on. We'll scale this thing up. So we watch that start. Resources. We can view the logs, make sure it comes up okay. And so this is our a customer mocking object that basically just feeds events into the system, right? But we can also jump into the machine itself right here, and makes it really easy to administer this, especially if you start debugging your system when you have like 7 or 8 microservices. Quarkus is pretty small, right? But I still have a lot of things running. To recreate this on my laptop, I've got a lot of stuff running. You wouldn't want to have like this many VMs in production. Would be pretty painful. So OpenShift makes it a lot easier to do microservices applications. It makes it a lot easier to do complex things like standing up Kafka. Right, so it makes it really much easier for us to do development, certainly dev test, but also to actually babysit these things through their full life cycle. I think that's actually the end of my slides and presentation. Like I said, if you would like to see, if you want the code to any of this stuff, feel free to grab this and play with it. It's still in, where's, it's in chat for you. Right, so to sum up, these things are, and we didn't look at, share my screen again for a second. We'll look a little bit more of the things that Quarkus. We saw this before, but Quarkus makes these kind of things really easy, right? So this is all we have to do to talk to Kafka, right? And if you've ever used Kafka's APIs, they're not necessarily the friendliest thing. So we just annotate this with incoming and listen to that topic. So when we boot up here, and grab it and automatically start listening to that topic, which makes it really easy. Makes it really easy to write this code. Same thing with sending it out. We just have an emitter object, and we just send this out, right? All we do is to JSON. We grab our object and we just marshal the JSON using a helper method. If you want to see what's behind the scene, it's not much bigger. We're using JSON builder, so I just have a little wrapper class to do that, but it just makes it so I don't have to import this everywhere. I just have this JSON util in my package. But it makes it really easy to marshal back and forth to JSON, makes it really easy to send this web update out. This is also using Java completable future. There's a little bit easier way to do this with Quarkus has a new feature called Mutiny, which is our reactive engine that can make this a little bit simpler. But it makes it very easy for us to do this, to spin this up really quickly, right? So this is not very verbose code, pretty efficient code to be doing a decent amount of work here. All right, so that takes us to the end of the presentation. Anybody have any questions or comments or anything in chat? Also throw this in chat too, start.quarkus.io.
I thought it was code.quarkus.io.
Through the guides, code.
Yeah, if you go to code.quarkus.io, you can quickly create a new Quarkus project from scratch.
You can also create one and push it directly to GitHub too. Is my video lagging for you guys?
Yes, a bit.
All right. Well, if nobody has any questions, comments, thanks for attending the session. I hope you guys enjoyed it. I hope you enjoyed Code PaLOusa. This is a very cool conference. I did not get to do workshops. I really hoped that I would get to do workshops, but unfortunately I couldn't break free. But I look forward. Hopefully next year we can attend. I'll be in Louisville in person. We can attend. We can actually attend in the conference. But guys, thank you very much. You want to reach out to either of us on Twitter? We're both available. And grab the source code. Slides will be up. I'm sure Chad will send them out, and then I'll put them out on SlideShare.
And for anybody who's interested, I will be at Heine Brothers on Bardstown Road Thursday morning with stickers, including Quarkus stickers. So if you would like Red Hat or OpenShift or Quarkus stickers, I will be bringing them with me.
All right. Thank you very much. We'll stop recording.
That'll be at 9 a.m. Thursday morning, the Bardstown Road, 1250 Bardstown Road location of Heine Brothers Coffee. It's a perfect place to talk about the Cafe Quarkus demo.